So if you have gone through the previous video and you have understood the concept of both the law, the conceptual understanding you are cleared through, then you can proceed with this video. If you still have doubt in the previous video, please don't watch this. You will not understand anything. Uh, Problem solving step for Kirchhoff law. Now, when you get a Kirchhoff law problem, there are certain informations given in the problem sometime, and sometime it is not given. Okay, and that what becomes confusing. So what are the information that a problem may give you or may not give you? So the first thing is the direction of current. So the direction of the current is not always known in the numerical which is given. Sometimes most of the book you will follow, if you CBSE level book or even J mains level book, you'll find the direction of the current is provided. But in some of the problem, the direction of current is not provided and you are supposed to find it. Okay, so let us first understand the step one. Okay, this is the step one of any problem, any Kirchhoff related problem. The step one, the first step is the direction of current. If the direction of the current is already provided, then you can skip the step and move to the step two. If it is not given, then you have to follow this step. Now what is this? Please sit with a notebook and draw this diagram. So pause the video and draw this diagram, everyone. Don't make or draw anything else other than this information. E1, E2 is the two EMF of this cell. R1, R2, R3 are the resistances. You have to draw the same diagram 3-4 more times. Now, direction of the current. As we have already discussed, I hope you all remember that when a cell discharge, that means cell gives energy to the circuit, it is discharging, then the current comes from the positive terminal of the cell. Current comes out from the positive terminal of the cell when the cell is discharging. This is the discharging condition. And when the cell is charging, then in that case, the current is supposed to enter from the positive terminal. So this becomes a charging condition. Now, when a cell can be charging or discharging, so if you put two cells like this, if you put two cells like this with some resistance in between, and the EMF of this cell, let's say this cell is 2 volt and this is 10 volt. So very well here you can see that the current will come out from the 10 volt and it is going to actually enter the 2 volt cell through the positive terminal. And in that case, this one becomes the discharging one and this will become the charging one. So the charging discharging of the cell depends upon their own EMF and the potential drop they are connected across and so on. That means in a given circuit, if there are multiple cells, some cells can be charging cells and some other may be a discharging cell. Okay. Or both of them might be a discharging cell. That is also possible. Okay, that is also possible. All combinations are possible. That means if I start drawing the current here, so let's say I take the current I1 from this EMF. I take this current I1 from this EMF E1 and I2 current from the EMF E2. Then I1 and I2 meet at this junction, and in this line here, I1 plus I2 will go through, and at this junction, I2 will come back to the cell it has come from, and I1 will come back to the cell it has come from. Now here we see we have assumed this particular current, the way the current has been drawn, it is assumed that both the cells are discharging condition because both the cells are giving out current from their positive terminal. Then we can also see that the current which leaves the cell I2, only that current is going to come back to the same cell. Under no circumstances no matter how complex the circuit is, you will have that a certain current is leaving the cell, let's say I2 leaving the cell, and I2 plus I3 or I2 minus I3 or I2 anything other than I2 enters the cell. If I2 has left the cell, only I2 will enter the cell. Okay. So this type, when this type of current is drawn, it is assumed that both the cells are in a discharging state. But obviously this is not necessary. You can also choose to draw the current like this. You can also draw the current assuming that the cell 1 is a discharging cell. It is giving out a certain current I. Then a part of the current at this junction is getting bifurcated, and a part of this current is going towards R1, that is I1. So I1 current is going towards the R1. So what is the current left now? The current that is left over is I minus I1. And this current is entering the cell E2. Then this current leaves the cell, the same current I minus I1 current leaves the cell E2, moves towards R2. And at this junction, this I1 is also coming back. It's also coming. So at this junction, both these current is coming, they will combine, that it will be I1 plus I minus I1. So these two will cancel. What is left? Only I, and that's why the I current goes back to the cell that has come out from. This type of current, if you draw, then you are assuming that this cell is in a charging, this cell is a discharging state, and this one will be in a charging state. And this is absolutely correct. There is no restriction that this will be wrong or this will be right, or this is correct and this is not correct in any way. You can draw the direction of the current the way you want to. You are absolutely free to do it. If the direction of the current which you have assumed comes out to be wrong, then your final answer would be negative. Something similar to what you have done in pulley related problems in Newton laws chapter, class 11. If you assume the direction of the acceleration of the system to be different, your final answer to be, if it comes negative, that means your assumed direction is exactly opposite to the actual direction. Here also same thing. If you assume this, if you assume this case and you solve your problem, let's say you assume this case and you solve your problem, and your direction, this direction of the current comes to negative value, let's say I minus I1, you are getting this as a minus 2 ampere. That means the direction that you have understood to be is not the actual direction. The actual direction is in the opposite. So you don't worry about the direction of the current. You draw the direction as it is, whatever, however you like, whatever comfortable to you. Again, there is no convention as such that should I be naming this one as I or this one as I1. No, there is no such convention. You can take any current out of it. You can just put this current, let's say, as I2, and here going I is going here, and then you can just change the number. I mean, the numbers, the representation of the current, it's all upon you. The direction of the current also all upon you. You only have to make one thing very, very clear, that the current which is entering the cell is the same current which is leaving the cell. So here you see the current entered the cell is I minus I1, the same current left the cell. This convention has to be followed. Again, you can also try other method, other current scheme you can try. So please try all the current schemes until you are not very comfortable drawing the currents. Until you're not very comfortable drawing the current in the circuit, don't proceed further. Okay, you will again get stuck up. So I will be giving you a few circuits here. Okay, few circuit, and you can draw the current in this circuit. Okay. So practice this drawing the current. If the current is already given, then you don't assume their current values, as in here I1, I2, don't assume. You can draw the way you want to. Anyhow, any current you can draw. Again, as I said, if the direction that you have assumed to be a wrong direction, then your final answer will be negative. No problem with that. Now, if you have already you're convinced that okay, that this direction of the current is comfortable, but mind it, only this, the direction of current is only required if the current is already not given in the problem. See, if you come across a problem in JEE Mains, JEE Advanced, CBSE board exam, anywhere where the current is already given, then don't force and make your own current, because the current is already provided. You only have to do the current this scheme of current thing only if the current is not given. Okay, only if the current is not given. Then also again, this certain misconception among students, that if they see this is at 10 volt and they see this is at 5 volt, so they will, and this is not misconception, so but you always try to take out the current from the positive terminal of the higher cell. This is kind of a convention. If you do this, your answer will be more synchronized with the actual problem. Because in actual also you will see that this 10 volt is going to give current to this one, and it is basically going to charge the 5 volt. The 5 volt is not going to charge the 10 volt. So try, if the values are already given and you are supposed to only draw the current, take the current from the higher EMF cell. Now that when you have already done this current part, then you proceed further, and then we are going to write the loop equation. Okay, we are going to write loop equation. So we have already done how many loops are there. I mean, how to identify loops. So in this case, you can very well see there are how many loops are there. There's 1, 2, 3 loops. How many? There are 3 loops. 1, 2, and the one on the outer one. This one. 3 loops are there. Now, once you start solving the loop, you will have to decide the position that you are going to start from. Okay, there is absolutely no convention to start any position. You can start your loop equation from this position. Assume that you are standing here and moving across like this, or you don't want that, you can start your loop equation from here and then you come back here. So you can start it from any point, but it is more convenient when you are starting from the cell. It is more convenient. Now, when you are starting the loop equation, that means again the same thing. You have to assume that you are walking in the circuit, as I told you before. You have to assume that you are walking in the circuit, and when you are walking in the circuit, you are walking in this direction. This is anti-clockwise direction, as you can see. Okay, you have to come back to the same point. You have to come back to the same point. You have to walk across the loop and come back to the same point. Now, coming back to the same point, so when you start, what happened? You first encounter this resistance here, R1. R1 resistance, you can see this current is flowing towards this direction. Here the current is flowing, and when you cross in the same direction, let's say from here to here, you will experience what? A higher potential to the lower potential. Higher to the lower potential, as you can see. That means this will be a potential drop. So potential drop will become minus of I1 plus I2 into what is the resistance? Resistance is R1. So R1, then you have reached here. You have reached here, and from here now you have reached here, you are now going to cross over this resistance. Here also you will experience potential drop. So you will write it here minus of I1 R3. Why I1? Because I1 was the current flowing in this resistance. And then you reach to this point. When you reach to this point, again you have to cross over the cell. You have to cross over the cell, and this will be from the negative to the positive terminal. Look closely. You are going to cross from this point to this point. Okay, from here to here. So crossing this negative terminal to positive terminal, so it will be a potential rise. And a potential rise of how much? Plus E. Now, because you have reached the same point you have started from, so this will all become zero. The sum of all this will become zero, and this is exactly what Kirchhoff's second law is. When you read Kirchhoff's second law, you may not understand a few things around it, but when you do the problem, you will actually get the very good hold of it. See, what was the Kirchhoff's second law? The algebraic sum of the change in the potential must be zero, and that is what we have just done. Okay, the algebraic sum of the EMF in any loop in a circuit is equal to sum of the product of current and resistance. So that is what the Kirchhoff's second law is. Now you have solved the first loop, but that is not done. You have to solve the other loop as well. When you solved the first loop, you moved in an anti-clockwise direction. So when you're going to solve the loop, the second loop, you again have to move in the anti-clockwise direction. That means you have to move in this direction. Do not absolutely solve the loop in the clockwise direction. You will get two equations which you'll not be able to solve it. You have to solve in the same direction. So that has to be an anti-clockwise direction. Now in an anti-clockwise direction, when you move, again you have to assume that you are standing somewhere here, somewhere near to the cell, and you are going to move. So when you move in this direction, you will come across this resistance R2, and this R2 is experiencing a current I2 flowing. But you are moving opposite to the direction of the current, and according to this resistance, this will be a higher potential point, and this will be the lower potential point. And when you move from here to here, you will find that there will be a potential rise. And how much is the potential rise? Because the current that is flowing here is I2, so the potential rise will become plus I2 R2. Then you move from here to here, and then this resistance will come. When this resistance will come, R1, again there will be a potential rise, because you're going to move from here to here. There will be a potential rise. You're moving in the opposite direction to the current. And potential rise will be how much? Plus I1, I2 into R1. Now that you have reached here, then you cross over and move, cross the EMF. Now when you cross the EMF, what happens? From this to this, there will be a potential drop, and the potential drop is always taken as minus. So it will become minus E2, and again the whole sum will become 0. So that is how you solve a Kirchhoff law problem. You identify the loop and you walk on the loop, and you do this potential rise, potential drop. You make the whole loop equation, and that will be your two equations. Once you get the two equation, again whatever be the unknown value, the question might be asking you about a certain resistance. So find out the current flowing from this resistance, or find out the current flowing this resistance, or maybe find out the unknown EMF, so anything. Kirchhoff law problem can ask you anything: unknown resistance, EMF, current, anything. But to know all of those, you need to write the loop equations. The equations are going to solve it, no matter what is the question is demanding: current, resistance, or EMF. For anyhow, you have to solve the loop equation, write the loop equation, and then solving it will get you whatever you want. Again, as I said, this is the step one, that the current has to be perfectly defined. If you miss on the step one, most students who think that they have doubt in this Kirchhoff law problem, they don't identify that their doubt is actually in current. Their doubt is not in the potential rise, potential drop. They are two separate things. Don't convert both of them. They're completely two separate things. First, defining the current in the circuit. If it is already there, then your half the job is done, and all that you have to do is this potential rise, potential drop, and the second law thing. But the first law wala part, that is the current defining part, that becomes very, very important. Okay. And again, there is no convention. You will find the same problem solved in different books using a different current conventions. Different types of current scheme they have drawn, and they have solved the same problem. They arrive at the same answer also. So it doesn't matter how you draw the current, it will always arrive to the same answer. So practice these questions, draw the loop and write the loop equation. This is not a theoretical topic, it's a skill that you have to develop by solving question. No matter how many times you see my video, it is not going to help. After a couple of weeks, you will forget everything. So you must draw circuits like this. I'll give you more problems like this, and draw this circuit, and then write the loop equation for all the loop. For example, write the loop equation for this loop, then this loop, then the bigger loop, And here also you can write this loop and the bigger loop and this bigger loop and all the loops that you can find it here. Write the loop equation, likho. And be very, very slow when you are doing it for the first few times. Okay, the rise drop, because one positive negative mistake if you have done anywhere in the equation, your whole answer will be incorrect. Okay, and all your effort will go down to waste. So make sure that you know the current properly, then the rise and drop properly, and then you write the loop equation. Now the next topic is related. It's the same thing. Sometime you may not get, sometime you may not get the whole loop. Sometime you can get a problem like this. So let's say this is point A, point B. Point has a potential of point VA, point B has a potential of VB. And this is the, let's say, the two EMF in the circuit, E1, E2, and then you have R1, R2, R3. And the current flowing in the circuit is like this. This is how the current is flowing. Now, if I ask you that you write the equation for this line, this is not a loop, minded. This is not a loop, but this is just a line. So if you write an equation for this line, what will you do? So you will start again, you will start here. And when you started at the point A. That means you had the potential VA. When you started, the point where you start, you will have that potential of that point. And then you moved across this resistance in the direction of the current. You will experience a potential drop here. So when you potential drop, how much? Minus of IR1. Then again you move across this EMF E1. Okay, you move across this EMF E1. So this EMF E1 potential drop you will experience because you are moving from positive to the negative terminal. So it will be minus of E1. Then you will reach here and now you will cross this. You will reach here and now you will cross this resistance. And when you cross this resistance, in the direction of the current, again higher potential, lower potential, so there will be a potential drop. So the potential drop will become how much? Minus of IR2. Now you are going to cross over this EMF. So when you cross over this EMF, you will experience a potential rise. Negative to positive you are moving. So potential rise, it will be how much? Plus E2. And then again this resistance here, you will experience a potential drop. So this potential drop will become minus IR3. And where did you reach at the end? Where did you reach? You reach VB. That means this will is all is equal to VB. Now, if you want to find the potential difference between VA and VB, so you can simply do VA minus VB. VA minus VB is equal to plus IR1 plus IR2 plus IR3 plus E1 minus E2. So that will be your potential difference between any 2 points. Okay, these types of question has become more common because the loop, the original Kirchhoff loop expressions and loop questions will be very large. You'll have to write 2-3 equations and thoda bada hota hai. So this type of question is more popular in JEE mains exam. JEE mains KSET, maybe this type of questions are because they are very, very simple and easy to solve, and Kirchhoff ka concept, all the concept will be used here. This very question can be extended or a bit more complicated. I mean, this question can be a bit more complicated like this. Just hold on. Now I can complicate this question a bit more. How? By putting more branches into this. So let's say I take another branch from here and I put a cell here and then a resistance and then a point C. And then I take another branch from here and do like this and make this a point D. So obviously the current which was coming here, let's say the current which was coming here, I, some part of this current is going to go here. Okay. Some part of the current is going to go here, and let's say that part be I1. So the part of current it moves on here will become what? I minus I1. Now again, I can take another current, which is, let's say, moving from here. Let's say I would take this as I2, but you see the direction of I2, it is moving towards this junction. So when this I minus I1 comes here, this I2 joins in. I minus I1 has come here, I2 will join it, and it will become what? The current here will become I minus I1 plus I2. Now I have a complicated circuit. I've just complicated just one step more, nothing complex as such. Just circuit I have complicated to look like complicated as such, nothing complex as a concept. So now again, if I ask you that you need to now move from point A to point C, okay, I have to move from point A to point C, and while moving so, you have to write the equation. So what will you do? You'll start with the loop equation, very simple loop equation, the Kirchhoff equation. This is not a loop. So sorry, this is not a loop. So equation, when you write it here, VA, you started off from the point A. So VA, and then this will be a potential drop here across R1. So the potential drop will become I times R1. Then again, a potential drop of this EMF. Again, the potential drop of this EMF. So this potential drop of EMF will be minus of E1. And then you move here. Then you move here, and here you are going to experience a potential rise. So let's say this EMF is E3 and E4. So the potential rise you will experience. So what will be the potential rise? Plus E4. And here, because the current, the current is going in this direction. This is how the current is going. So you are again moving in the direction of the current. So here you see you are moving in the direction of the current. The current is moving here, and that will become minus potential drop as minus of I1 R4. And this will be is equal to VC. So you can then find the value VA minus VC. VA minus VC, that is potential difference between 2 points in the circuit. By similar method, you can do VA VD or VA VB or VC VB or VD VB. You can do any combination. All that you have to do, that is to walk from that thing that you are walking from here to the point you want to go, and keep on doing the potential rise and drop and rise and drop wherever you come across, and you can find the potential difference between these 2 points. So practice this right now. Find a loop, find the equation for VAD, VBC, VBD, okay, VDC, okay. For all these combination, find such equation, and it will be quite clear. So all in all, this is the basic steps and techniques to solve Kirchhoff, but it required considerable practice to master this type of problem. If you don't practice this problem, you will not get it through. And practice means not 2-3 problems, at least 10 to 20 problems you must practice. I'll give you through to get this good grip on this topic.